So this function will have an inverse because this function's graph is a line and the line's not horizontal or vertical. So there will definitely be, it's definitely a one-to-one function that passes the horizontal and vertical line test. The question then becomes, how do we find the inverse? How do we find a formula for the inverse? And the answer is you do the following steps always. Always, always, always. First, replace the function notation with y. Then everywhere you see a y, put an x. And everywhere you see an x, put a y. You're switching the x's and y's, which is the fundamental idea of an inverse. Then in order to graph this, the next phase is to get y by itself. So we could add a y to both sides. I've added a y here and I've added a y here. And we could take away an x from both sides. Taking away an x here and taking away x here. And now we replace this y with the function notation for an inverse. It looks like f to the negative 1 power, but it just means the inverse function of f. The inverse function of f. And so that's minus x plus 12. And so we have 12 minus x and minus x plus 12. Those are inverses of each other. So this time we're going to find the inverse of f like we did on the last problem, but then we're going to graph the function and we're going to graph its inverse all on the same set of axes. And we're going to see a relationship that a function and an inverse always has. So let's get started. First, we put a y instead of the function notation. Then everywhere we see a y, we put an x. Everywhere we see an x, we put a y. And then we solve that for y. So I'm going to take away 3 from both sides. And I have 2/3 y on one side equals x minus 3 on the other side. Then to solve for y, I'm going to multiply both sides by 3/2. So here I'm getting y equals 3/2 x minus 9/2. Or if you prefer, minus 4 1/2. Then lastly, I replace the y with function notation for the inverse function. And then I'm going to graph these two on Desmos. Let's see how that goes. So I've graphed the function f. It's red. I've graphed the inverse function. I didn't bother to try to make inverse function notation f to the sort of the negative 1 power kind of looking thing. I just called the inverse g of x. And so there's the function and its inverse, and I suppose that that means almost nothing to you. But there's kind of an interesting fact. Do you remember that when we were finding the function that was the inverse of f, that I called g, do you remember that on one of the main steps we reversed y and x? Everywhere there was a y we put an x, everywhere there was an x we put a y. This line right here, y equals x, is kind of the line that's built out of points where y and x are reversed. And watch what happens when we graph y equals x. Watch closely. Y equals x is a line of symmetry. The function, the red function, and its green inverse are symmetric around the line y equals x. A function and its inverse should always be symmetric around y equals x because you're inverting the y and x's. You're labeling y's as x's and x's as y's. And so one way you can check your work on problems where you're trying to figure out an equation or a formula for a function and its inverse is you can graph those two and then put the line y equals x and see if there's symmetry. Of course, if you were doing these graphs by hand, it could take quite a while. But we don't have to do these graphs by hand. We get to do them on Desmos, which is makes it very easy to learn.